My name's Daniel Hens. I'm a meteorologist here downstairs. I work with Steve Waters in the flood warning branch as well as Chandra Miller. Again, our focus is with the alert system, weather, flooding, all that good stuff. For today, I typically, if you've been a part of these, this is going to be my 11th one of these outlooks. I kind of like to start out. This is one of my favorite images from Forrest Gump, with that whole idea that, life is like a box of chocolates. You never know what you're going to get. The monsoon's very much the same way in that every year, we have really wet years, really dry years. The image behind me is our alert network. You're looking at rainfall totals going back 45 plus years. Average rainfall during the official monsoon season, and again, average across the county. And you can see we have years that are very, very wet and very, very dry. Our mean, when we look at the long term, is right around 3 inches. So we have a unique scenario in the last 2 summers. Again, if you've been around the Phoenix area, we have the extremes. As far as extremes go, we had a very, 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 very dry 2020. We all wanted to forget that and never think about it again. We've also had a very wet 2021. Moving ahead, I know a lot of you are curious, so what can we expect for this upcoming summer? And I can say with a lot of certainty, we'll probably not be as dry as 2020 and not as wet as 2021. So let's get into this here. So for today, talk about why we're active or why we're bullish about an active upcoming monsoon. We're also a little cautious. There's a couple of things that, based on our historic data, giving us a little bit of concern. But ultimately, we'll kind of summarize this, and you can take it as you will. And let's start off with just a quick monsoon refresher. So the season officially runs from June 15th to September 30th. For any of you that have lived here for a while, though, the onset of actual storms usually gets going closer to the 4th of July weekend, actually. And the way we used to keep track of that was 3 consecutive days at the airport with dew points over 55. Nowadays, though, again, June 15th to September 30th. In terms of the rainfall itself, the airport sees around 2.5 inches during the monsoon. Again, our county, when average, is right around 3 inches. And that usually equates to about 30 to 40% of the rain we see each year. And in terms of number of active days, usually we're looking at somewhere in that 10 to 15 days during the whole length of the monsoon, where we actually see a lot of activity right here in the valley. In terms of the underpinnings of the monsoon itself, typically winds blow from west to east here. Our storm systems come off the Pacific. They move across the desert southwest. They bring us our rain, cold fronts. During the monsoon, we actually get a significant shift in the winds and where our moisture sources are. And again, we start to see this easterly or southeasterly flow. So the way this actually happens is we have strong heating during late June and into the early summer that helps build this monsoon ridge. As that ridge builds north into the desert southwest, clockwise flow around the ridge helps bring mid and upper level moisture in from northern Mexico, the Gulf of Mexico, the Gulf of California. We also get intense heating during the summer. Of course, it gets very hot. So we have this other feature, this thermal low, again, helping pull moisture up and out of the Gulf of California into Arizona. We'll start to see thunderstorm activity across the higher terrain mid, late June, early July, and then hopefully we get outflow boundaries and other things that can help assist getting storms down into the lower deserts. And again, if we're lucky enough, we might actually see one of these thunderstorms, which is represented by that mark there in the valley. The main key that I want you guys to take away here is, in order for all these storms to really get going, we really pay attention to that monsoon ridge, that H over there with the clockwise spinning. There's certain climatologically beneficial spots where that ridge can settle that become very favorable for us to see storms, rain, all that activity that we like to see. And these are kind of our 4 main ridge locations that we look for. The 2 most prevalent during the height of the monsoon is this top left, the Four Corners High, which I kind of just talked about there. We also have a Great Basin High. That's kind of our rim to valley pattern, where all the higher terrain activity moves from up in the Payson area off the Mogollon Rim and down into the valley. It can be very, 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 very active pattern. We also have an early season and a late season pattern here, this West Texas, New Mexico High. That's our all or nothing pattern, again, because usually we need the help of the ridge as well as a low pressure system, maybe some moisture shed from a tropical system. But these can be very big rainfall producers. And then we have a little lesser known trapping high setup. Again, we see from time to time, but again, much less prevalent than the other 4. So ultimately, though, it's all about getting that ridge to sit in one of these positions to, again, help increase our chances for rain. If we want to look here, you can see that red H, that's our monsoon ridge across far east Texas. We actually have a cutoff low pressure system off the coast of California. And of course, Arizona is in southerly flow right in between there, as well as New Mexico. So why we're bullish. So here are a couple of things that we're looking at in terms of before the season starts that help give us an idea that maybe we might see an active and potentially wet season. So starting off, we can look at the Climate Prediction Center produces these long-range 3-month, this is for July, August, and September. They look at temperature versus climo as well as rainfall. And as you can see on this first image here, above normal temperatures are pretty much favored across almost all of Arizona, and of course the Phoenix area. Again, that favored outcome during the length of the summer. But what we also see here is that where above average precipitation is actually the favored outcome. Again, it's not a strong signal, as in it's not like 60–70% chance that we see above average rainfall, but the fact that we're not in this below normal or near normal, we actually have this wet bias is a good thing to see, again, giving us that potential. So these are produced by the scientists there. They're using long-range statistical models as well as dynamical models. They're looking at soil moisture. They're looking at teleconnections like El Nino, La Nina, other oscillations, and they kind of put it all together. So again, it's always good to see this kind of signal. So that's our first bullish sign that we've seen. Talking about ENSO, again, El Nino, Southern Oscillation, we are currently in the La Nina form. And so what that means is we actually have colder than normal sea surface temperatures along the intertropical convergence zone across the Pacific. And that's kind of what's showing in this map on the top hand right side there. Those blue shades there say that the normal sea surface temperatures are actually colder than average or colder than normal than what we typically see. So you can see that blue line extending across what would be South America and then over into the maritime continent. As far as where we're at this point, we're straight in La Nina. La Nina is expected to weaken a bit into the summer and fall, and possibly we go into neutral. But the point being is no signs of El Nino. We're still La Nina. And again, this comes into play when we start talking about bigger scale things like where that ridge sits, or hurricanes, or long-term rainfall or temperatures. And that's what we're going to talk about here moving ahead. So I show this every year. This is a map. So what we're doing is we're looking at the last bunch, we'll call it 50, 60, 70 years worth of rainfall data across Climate Division 96, which in the map on the top left there you can see is basically all of south central Arizona, including parts of the Mogollon Rim area, Maricopa County, a little bit areas west. And we break that down into La Nina, neutral, and El Nino. We happen to be in the La Nina side of this, and we can do box and whisker plots that kind of help us look at the distribution of what we might expect. And to keep it simple here, what you're seeing basically in that box highlighted in blue there with the red line and going across, the main point here is that most of our events tend to fall within that box. And what we can see there is in terms of average rainfall, that's in that 3 to 4 inch range. That's one of the higher and more wetter outcomes when compared to maybe if we're in neutral or even at the El Nino phase. So again, being in La Nina is usually a good thing. It doesn't guarantee you a ton of activity and rain, but if we look overall our historical perspective, it's a good thing. Now let's take a quick look. So we're looking at the whole kind of Eastern Pacific here. We're looking at sea surface temperatures over the last 30 days, the anomalies. So blues are areas where it's colder than normal. Yellows, oranges, and reds are where it's warmer than normal. I can highlight the intertropical convergence right along the equator area. You can see the La Nina with little bouts of warmer water mixed in there. But really what we're moving to now is we want to look closer to home in the Gulf of California. And what we can see as this plays on, we're going from blues or colder than normal to yellows and oranges and even some reds, saying those temperatures are warming up and they're warmer than normal. And another way we can take a look at this is to see how fast they're actually even getting warmer and colder. And again, if you watch up in that zone as this plays on, we can see we're getting in anywhere from 0.5 degree, 1, maybe even 2 degrees Celsius per week, which that area is currently warming, which we normally see this time of year, right? Because it's hot. The ridge is building north of that spot. But how much warmer it is than normal can help tell us on maybe when we see the onset of the actual thunderstorm activity. So there's been numerous studies that have been done that talk about the average sea surface temperature in the Gulf of California. And the key number we're trying to look for is 27.5 degrees Celsius. And we can track that throughout the Gulf of California. What you're seeing right here is the temperature as of last week. And if we kind of break it down by zone, we're anywhere in this, basically about 26 degrees if you approximate it across the whole way. So we're within 1.5 degrees of where we want to be, where traditionally we get 90% of our rainfall after we pass that 27.5 degrees Celsius. And that previous slide was also showing, we're warming around 1 to 2 degrees per week right now. I mean, we're probably basically here right now. It's all kind of falling in line for an early onset. So maybe we don't actually have to wait all the way till the start of July. We're getting going a few weeks early. That's a good thing. The sooner the storms start, the better chance we have to get rain, the better chance we have it being wetter than normal. The next thing I want to talk about, and again, this ties into La Nina a bit here too, is if you look back, you're looking at the percentile for rainfall from last December through April. So greens mean wetter than normal, whites are right around normal, yellows and oranges mean drier than normal. It's pretty obvious to see here, I've kind of tried to highlight there with that red line, that most of the Intermountain West, Central and Lower Rockies, Desert Southwest have been quite dry. I mean, there's pockets here where, you know, there's been decent rain over the winter and spring, but in general, it's very dry. And typically what we've seen, and based on some of the historical research that's been done by Higgins et al. In the 80s and 90s and some of our other folks that have looked into this, we tend to see after dry winters a better shot at getting that monsoon ridge north. And the further north we can get, the sooner we can get it north, the better chance we have of pulling in moisture and storms. So this is typically something, when we see this dry winter, we may end up seeing, you know, that wetter summer. So there is some analysis and work that's been done to actually show that there is a link there. So, and again, this makes sense because La Nina winters tend to typically be drier than normal. So it all kind of ties in together. But overall, this whole kind of picture we're pointing is an early onset and a decent chance, at least historically speaking, to see an active summer. In the near term, you're looking at the Climate Prediction Center right here. This is looking over the next 7 days. So this is valid basically for next week, the end of this week and into next week. You can see we have a bullseye for above normal precipitation across the Four Corners region, which is great. Again, this time of year, any kind of measurable rain is great. And really, it only takes a few drops to get us to right what we'd see normally anyways. So don't get carried away. But again, it's good to see that this wetter than normal bullseye right there. And if we skip ahead even a week ahead of that into the 4th of July weekend, we're still kind of in this above normal regime, which is great. And then we can look even further ahead for the whole month of July and what we're anticipating. Again, we still see this wet bias. So all these things are kind of telling us early onset, possibly an early start through the first half of the monsoon. This is all really, really, really good. So I just went through kind of explaining our case and why we're bullish, at least to start out. Here's where a little bit why we're hedging still, why we still have a little bit of concern. And the first thing I want to talk about, again, tying into that La Nina, is typically when we're in a La Nina phase, we see enhanced hurricane action, but over on the Atlantic side. We're on the Pacific side. The influence we feel tends to be from the Eastern Pacific, and during La Nina, we tend to see slower than normal years, and that's no exception. The Hurricane Center put out their forecast a few weeks ago predicting a below normal as the favored outcome. So they're anticipating something on the order of 10 to 17 named storms, 4 to 8 hurricanes, you know, a couple, maybe none though, but major hurricanes. And compared to average, again, much less than what we see. Last year ended up being below normal, and it was predicted that case. We have seen a couple of tropical storms, right? I already mentioned blasts, and there was a storm before that. And again, this mid to late June, regardless of whether you have a busy or a slow season in the end, this time period in the Eastern Pacific is usually pretty active. So what we tend to see is as you get into August and September, normally the peak hurricane season, that's when things tend to slow down in the Pacific, and maybe they're a bit more active over in the Atlantic. And again, that's not something we necessarily want to see for here in the monsoon, because when we start getting into those end of season bigger events, you know, the West Texas high where we can actually pull moisture up from the tropics, we may not have any moisture to pull up if that situation arises. So again, second half of the monsoon, maybe less of an opportunity to see one of these systems pull moisture up and give us you know, increased rain chances. So I mentioned again the La Nina. So one thing that we do notice is when we're in a strong La Nina, strong El Nino, one of the things that we tend is that the pattern becomes a little more amplified. When I'm talking about the pattern, the upper level pattern, so where we put ridges, where we put troughs, where the jet stream, which actually kind of moves low pressure systems and high pressure systems around. So when we get into these strong patterns, you start to see amplification, and things tend to exist in spots where maybe they don't. So we're looking again, we want this ridge to be in that Four Corners region, the Great Basin or the East Texas area. We tend to see more drifting of the ridge during the La Nina or strong El Nino. And if we're in one of those great spots or one of these favorite spots, that's great. But if the ridge continues to drift, you know, farther east or up in the far north Great Plains, that won't necessarily do anything for us come, you know, mid-late monsoon. Because again, it's harder to get thunderstorm activity if we're not in one of these kinds of setups. So it's just something to keep in mind. And I kind of wanted to go back and start digging a little bit more into, you know, previous La Nina events, and not just single year, but multi-year. So our current La Nina event really got going actually in 2020, and it's persisted all the way into 2022 now. So I went back in the records and took a look from 1950 on. multi-year La Nina events, and then how Phoenix did, again, over at Phoenix Sky Harbor Airport through the length of these multi-year events. And we have 6 different events here. And not that there's any huge patterns that we can pull out of this, but what we've seen is that there's always, of course, definitely a wet year, but there's also dry years that are worked in to when we see these multi-year La Nina patterns. So we've already had a really dry 2020. We had a very wet 2021. I mean, based just on a first cursory glance here, you know, we have a dry and a wet and a dry, and then a wet and a dry, but we're not seeing like multiple years of wet or multiple years of dry. So again, I don't know that there's any guarantee. This just kind of lets us know that, again, it's not a guarantee that we'll be wetter than normal. So again, we're still really bullish. We still expect an active monsoon, but don't bet your life on it. So I'll kind of end it with this here again. We are expecting an active monsoon. There will be plenty of storm activity, especially we're really excited from now through the month of July. It looks like it should be quite active, and we should have lots of opportunities for rain, not only here in the valley, but across Arizona, across the desert Southwest. We have observational data as well as statistical model data, all kind of pointing the same direction. This is really good. They're also seeing this warm, above normal temperatures favored throughout the entire length of the summer. We touched on that briefly. So again, it's summer. It's going to be hot, of course. But again, we're not putting all our eggs in the basket, especially looking for the middle of the monsoon in the second half. Just again, slower hurricane season, the ridge becoming a little more erratic later on in the year. We might see kind of an abrupt end. Even last year, which was super active through July and August, it kind of shut down at the end of August and never really got back up and going after that point. Maybe we'll see something like that again this year. Maybe not, but it's just worth noting. I always like to say that it really only takes 1 or 2 big events for us to reach that, 2.5 inches or whatever at the airport, where we're officially saying whether it's a wet or dry monsoon. Really, 1 or 2 events can get you right there. Again, any location in the Phoenix Valley, Maricopa County for that matter, it just takes enough rain in the proper duration to cause flooding. And again, it doesn't take that much rain. So we see flash flooding problems every year, whether it's a slow year or a really busy year. So we just want you to take note of that. And then again, we always want you to prepare. We've got a great website set up here. We're going to maricopa.gov monsoon. You can find information on how to plan ahead of time, as well as when rain and flooding events are occurring, and then what you need afterwards. Great resource. Please take a look at it.